Welcome to ThinkData, helping third sector organisations to make better use of data. Find out more at www.thinkdata.org.uk. So we're thinking about cases where you have data that has some geographical component, some spatial component, and you want to be able to visualise that variation and explain how your data varies across some sort of geography. So the first approach might be to use a standard geography, so some standard measure of an area which you can then present your data by. And there's a wide range of standard geographies of different sizes. At the lowest level we have data zones. This is a standard statistical geography of which there are about 6,500 in Scotland. Each data zone has about 500 people in it. So within cities they're quite small areas. Within rural areas they can be slightly larger areas. But they have a sort of standard amount of people in them. And we have a wide range of statistics available at that data zone level. Above that we have intermediate geographies which bring together communities. We have some administrative geographies such as the constituencies for local councils and for the Scottish Parliament. And above that we have local authority areas covering much larger geographic areas, and geographies such as health board and community health partnerships that bring together larger administrative areas as well. So these are standardly defined geographies of different size that we might want to use in presenting our data. So one example of this would be presenting summary statistics by a geographical classification. So for example, the volunteering rate presented by local authority area. So in this table we can see how the volunteering rate varies across different local authorities and examine that variation. A table like this is going to be effective when you have a smaller number of larger geographies, so that the table isn't ridiculously big, and also where the location of the geographies is relatively well known to the audience for your table. So they understand what the different local authority areas, for example, mean and where they are in relation to each other, at least to some extent, so that the variation across them is meaningful. And it may be the case that you need to group some geographies together. For example, in this table, the small sample in some local authorities has led to them being grouped together as a southern Scotland category. So where you have some geographies with a relatively small sample, you might want to group these together in order to produce reasonable statistics by those areas. What the table doesn't show, though, is the spatial relationship between these geographies. And obviously the natural way to present that is through some form of mapping. So this map of Scotland shows the local authority areas, and these areas can be given different colours to communicate different values of some variable that we want to present. And the advantage of the map is that it clearly communicates the spatial relationship between the different areas that we're presenting data for, that it's easy to see where places are in relation to others. We use colour to indicate the variation, so you can see we have a continuous variable here that has been coded into categories. There are colours associated with those categories, and then each of our geographies is appropriately coloured for the value of that variable for that area. And an advantage of mapping in this sort, as well as being able to show the spatial location of different geographies, is being able to communicate the distribution and the variation across space of the data that you're wanting to present. So it's quite easy to see the different values and how they vary across a country. But we also want to think critically about this sort of presentation. Here's an example showing the average volunteering rate from the Scottish Household Survey, using data from 2007 to 2011, and it is presented by local authority area. So we can see there's significant variation in the rate across Scotland, and this is shown quite strikingly by the different colour of the different areas corresponding to different volunteering rates. But one of the drawbacks is that physically larger areas dominate the map. So our larger local authority areas are going to be larger blocks of colour, despite having relatively fewer people. In addition to that, then underneath that larger area, the variation is understated. We have a summary statistic for a relatively large geography, but it doesn't present how our characteristic, how our volunteering rate might vary within that geography. And then where we have areas with larger population density, so the cities in the central belt, the geographies are physically much smaller, and it's much harder to see the variation. So the areas where we have the most people and where we have a lot of variation in volunteering participation takes up a much smaller space in our visualization, and so it's much harder to see that variation from looking at the map. We also have to make some choices about the colours and categories that we use. So you can see volunteering participation has been sorted into a number of categories and colours assigned to those categories, and there's a decision to be made about how large those categories should be, how many categories you should have, whether they should all be of similar size, and then colours have to be assigned to those categories. And there's not necessarily an obvious ordering to colour, so in this map it's not that straightforward to see which colour means a higher rate and which colour means a lower rate without looking closely at the key. An alternative to mapping by standard geography is to actually map individual units within your data. So whether those are individuals or households or organizations, if you have location information about your data, to actually plot that location. So this example here uses latitude and longitude data for postcodes in order to produce a scatter plot where the location of the points is related to the location of the underlying data. And as well as then showing that physical distribution, you could then use colour within those dots to communicate different values of a variable and how it varies across space. What this sort of graph is particularly good at showing us is denser and sparse areas, and the variation in our data across space. What we have to be careful of if we're trying to communicate different values of another variable in this sort of plot through the use of colour is the size of our dots and whether dots are close to each other, whether they're being plotted on top of each other as to which colour is going to be dominant. So we need a bit of care in that choice and presentation. And the other issue is that it's not necessarily that clear from looking at this sort of plot which area is being presented. So whether you can tell from the shape which part of the country it is, and if you can, whether you know the area well enough to be able to identify what those more dense and more sparse areas might mean, and so actually interpret the geographical variation. If we put a map of this area alongside, we can see that it is broadly the Strathclyde area centred around Glasgow, which explains some of the distribution of those points. But without putting some more cues onto the map itself, it can be difficult to interpret that variation. There are some alternatives to purely spatial mapping that we might want to consider. So essentially the problem is that our geographies vary in size, and particularly our rural geographies might be physically larger than our urban geographies, and they don't capture the underlying population density. That areas with that are quite small probably actually have quite a lot of people in them. So this map illustrates that for England, where we can see there's quite a lot of variation, quite a lot of detail in the London area, but that's pretty small in the map. Most of the map is taken up by larger areas in the rest of the country. So we really lose that variation which we're trying to communicate for those areas that are most densely populated. So an alternative to that is a cartogram showing the map resized by population density. So now these administrative geographies are scaled according to the number of people that are in them rather than by their physical size. And we can see this distorts the map so that now the London area takes up quite a large proportion of the area. We can see those areas within London. And some areas, such as Devon and Cornwall, are now much smaller, representing their much lower population density. So we start being able to see in more detail that variation in more densely populated areas, rather than distinguishing our areas just by their physical size. Here's another example presenting GDP data for Europe. And it may take you a moment in looking at this graph to realize that it is showing Europe, that is what is being portrayed. So this gives us a better representation of the variation, but we do have to ask how easy it is to see where the map is meant to portray. So it maybe took a moment to realize it was portraying Europe. Having realized that, we can pick out London, we can pick out Paris, other key cities in Europe might be reasonably apparent, but outside of that it's much more difficult to interpret where some of the places might be when this map is distorted. So we can see variation across Europe, but actually picking out more detailed information from this map without having a really good understanding of the geography can be more difficult. We also still need to make good choices about the scale of the data that we're presenting and the choice of colour that we use to present that variation in order to be able to communicate the underlying data. So a third approach that we might want to consider is summarising our data by characteristics of the areas rather than just by the geographical areas themselves. A common example of this is to look at rurality, and the Scottish Government publishes both a 6-fold and an 8-fold classification of rurality for Scotland that takes into account both population size and accessibility, and then classifies in areas in Scotland by that level of rurality. So we can see how rurality is distributed across Scotland as a whole. If we zoom into central Scotland, we can see it's split up into different areas, and each of those areas is coded with a level of rurality. So areas with the same rurality in the centre of cities, for example, have the same colour and the same level of that categorisation. We can then think about presenting summary statistics by those different area characteristics. So this groups together all the areas that have the same level of rurality, so all the areas that are in large urban, all the areas that are remote rural, and so on, and then we can produce summaries of our data by these categorizations. So this is grouping geographies together where those geographies share a common characteristic, even if they're spatially far apart from each other, but they have an equivalent level of rurality. And one of the advantages that brings, again, of grouping together geographies is that it helps us when our sample size is smaller. That creating smaller numbers of groupings is going to give us a larger sample size within each grouping in order to be able to present sensible summary statistics. But one of the things that we do need to think about carefully is what it is that that area characteristic is actually capturing. So what does it mean to combine different communities together when they have equivalent ruralities, to combine urban areas in quite different places together because their level of rurality is the same? And how does that relate to the data that we're presenting? Does it make sense to look at variation across this area characteristic without taking account of exactly where areas are? Another common measure of area characteristic where we also have to think about these issues is the Scottish Index of Multiple Deprivation, or SIMD. So this combines information on employment, health, education and other measures for local areas at the data zone level in order to rank all the data zones in Scotland. And so it provides a measure of relative deprivation where we can look at areas that are more and less deprived, and then we can produce summary statistics based on those area characteristics. So this graph shows the volunteering rate in Scotland, comparing the 20% of most deprived areas to the rest of Scotland and to the national average for Scotland. So it lets us start to capture differences between communities based on their level of deprivation. And in volunteering we can see some quite large differences. But again, we need to think carefully about what it means to combine different communities with the same values of these area characteristics together, and what sort of variation we might be losing by doing so, and how that grouping relates to the data that we're trying to present and the message that we're trying to communicate. So again, you need to choose appropriate groupings for the area characteristics. It groups into a smaller number of categories, but you need to think about how similar the geographic areas that you're combining are in terms of that area characteristic. Here's another example of presenting data by SIMD. This graph shows healthy life expectancy, and areas have been grouped into quintiles. So there are 5 categories of deprivation here, from the least deprived on the left of the graph to the most deprived towards the right of the graph. And this shows some quite dramatic differences. So we can see that healthy life expectancy is much lower in the most deprived areas than it is in the least deprived areas. So it tells quite a dramatic story of inequality across areas ranked by deprivation. Another of the advantages of grouping these geographies into a smaller number of categories, 5 in this case, is that we can then bring in other factors into our presentation of the data. So this graph captures trends in time as well as space. So it shows that healthy life expectancy has been increasing across time, but that this increase across time is pretty small compared to the big variation by deprivation. Of course, there are going to be a number of other factors that affect both deprivation and health, and so we have to be careful in showing some of these more simplistic comparisons, that we understand what we're not taking in account of when we group together areas and when we get rid of that variation. But this sort of presentation can tell quite dramatic stories about the differences between communities. So there are 3 key points that I would like you to take away in thinking about summarizing and visualizing geographical inequalities. First of all, you need to choose the appropriate level of geography. There are really quite detailed geographies such as the data zone, and there are quite broad high-level geographies such as local authority. You don't want to have too low a geography because the sample sizes will be too small and the differences that you show will then really just be down to random noise. But you don't want to have too big a geography because you'll be throwing away a lot of the variation and a lot of the pattern that you might be wanting to communicate. So you need to pick a geography that's appropriate to the data that you're presenting, to the sample size that you have, and the variation that you think it is realistic to communicate. Secondly, you need to think about how best to present that data. Does it make sense to put it in a table because there's a small number of geographies and the audience will understand what those geographies mean? Is there a need to organize the geographies spatially, and so it makes sense to do some mapping? Or are those maps going to be distorted by different sized areas, and so you need to think about some of the alternative presentations of mapping, such as scaling by population density? And then thirdly, you might want to consider the alternative of summarizing by area-related characteristics rather than by those geographies themselves. And examples include rurality and deprivation. But you need to think quite carefully about what it is you're measuring and how those area characteristics relate to the data that you're presenting in order to be able to understand what it is that the data is telling you. So this session has given you an overview of some of the common methods for summarizing and visualizing geographical inequalities, and has also suggested some of the potential issues that you might want to give careful consideration to when describing spatial variation in your data.